Okay, so another method of finding Nash, which is a very simple method and which is used in a lot of complicated games and which we will be using when we do imperfect competition, is we call it best response functions. Now, as the name suggests, it's a best response to something. So what is a best response function for a particular player? It is the best action that player, say player 1, can choose given the action of all the other players. Or if it's a two-player game, we can simply say that best response function of player 1 will be the best action of player 1 given various actions of player 2. And the way we define best is very easy and simple. That action is considered to be best, which gives the highest possible payoff to a player. So if we have a complicated game, and especially games which have continuous actions, like we'll be doing in imperfect competition, then best response function is the easiest thing to work with. So to define it, for any given action of the players or all the other players except player I's action that yield her highest possible payoff will be the best response of player 1. So suppose if we go back to any particular game, let's go to the Battle of Sexes game here, and yes, let's use the best response there. So music game. Actually, I have been finding Nash till now using this method only, but we are just formally using it now. So if I ask you a simple question, given that player 2 has played movie, what is the best action of player 1? Now the best action is that action of player 1 which will give player 1 the highest payoff given that player 2 has played M. And the answer to that is that player 1's best action is M, given that player 2 has played M. So if player 2 has played G, then what is the best response of player 1? If player 2 has played G, then the best response of player 1 is to play G again. And likewise, we can ask these questions for player 2 also. That means we can check what will be the best response for player 2 also. So we can write it in a different format here. I'm writing it like this. B1. B stands for best response. Subscript 1 says best response of player 1 if player 2 has played M. Now, whatever we are writing in the bracket here is the action of the other players. In this particular game, there's just one player. If there are more than one player, then that means it would be BI A minus I. So, best response of the ith player given that the other players are playing this action profile. So, best response, for example, in this game of player 1 when second player has played M is equal to M only. Sometimes there can be two best response also or more than one best response also. Okay, so if you write it formally, this is equal to AI in action set of player I. And it will be best response because the utility that player I will derive from AI when everyone else is playing A minus I will be greater than or equal to or UI AI prime A minus I for all the AI primes in action set of player I. So it simply means a particular action AI is the best response to AI A minus I, that means actions of the other player, if the utility which player I gets from action AI when others are playing A minus I is greater than or at least equal to utility of any other action or rather all the other actions of player I given that others are playing this. That means for a best response, the utility or payoff, whatever we may consider, is greater than or equal to other actions. Okay, if you remember in the last game when we were talking about strict and non-strict equilibria, then there were cases where choice were out of two actions for player 1, and both the actions, if you can go back to figure 33.1, and both the actions T and B were leading to same payoff for player 1. So in that case, this greater than is not valid, it's equal to. So therefore we are using greater than equal to. So it's a weak inequality that we are using here. So this is the way we define the best response function. So we can define it for player I, we can define it likewise for all the players in the game. So in this case, this is for player 1, and if we change the action of player 2, the best response will also change. So if player 2 has chosen G, then the best response of player 1 will also change. Okay, likewise we can write best response function for player 2 also. So, and if it's a multiplayer game, we can write it for all the players there. Now we'll be using the best response function to find Nash equilibrium. We know what is a Nash equilibrium. Nash equilibrium, simply put, is that action profile for which none of the players have any tendency to deviate, given that other players are adhering to their Nash actions. So that would imply that none of the players can benefit from deviating from their Nash action profile. That means that their Nash action profile is giving them the highest possible utility or highest possible payoff. So that would mean that in a Nash equilibrium, every player is playing their best action given what other players are doing. So if we can just write it or read it from the book, it's proposition 36.1 in the book. It says the Nash action profile A star is a Nash because if every player's action is a best response to the other player's action. So what does it imply? A Nash equilibrium is simply that action profile in which every player is playing their best response. That means AI star, remember star we've always used for Nash equilibrium, is in BI. BI is the best response of player I, or if it's more than one action, then it becomes a set. Then every Nash action of every player is in the set BI A minus I. Now A minus I is what other players are doing, and BI A minus I becomes the set of best response of player I, given that other players are playing this, and this will be true for all I's. So this would simply imply that AI star, which is a Nash equilibrium action of player I, will be for all the players I. So if it's a two people game, then A1 star, that is the Nash equilibrium action of player 1, will be the best response to A2 star. Again, A2 star is the action chosen by player 2 in the Nash equilibrium, and so this is one here, and this would be if it's a two people game. If it's a multiplayer game, then we have to write it in this form. Okay, so we quickly do an example here. It's figure 37.1. Again, there is no story behind this. It's a bowling game here. So 3 actions for all the players. So it's a 3 by 3 game. So we will be having 3 rows and 3 columns here. So we have